in this question, we're asked to model a bullet that's going into a block. So it tells us that the bullet is fired from the gun at a speed of 120 meters per second. And it wants to know, after 0.4 seconds, that's the time it takes to hit the block, it wants to know what the speed is at 0.4 seconds. So we're going to use differential equations to first develop a mathematical model of the system, then solve the model, and then we can find the velocity when time is 0.4. So first things first, free body diagram. Now a free body diagram shows all the forces acting on your system. So after the bullet is fired, there's no more pushing forces, there's only a resistive force, and that resistive force acts against the motion. The magnitude of that resistive force is 0.001 v squared. So it's a square model of drag force basically. Of course we have the mass is 50 grams, so the weight is going to be 50 divided by 1000 to convert it to kilograms, multiplied by the acceleration due to gravity. Then we have also some kind of, if you can call it a reaction force, basically keeping the bullet horizontal. So R is equal to 50 over 1000 times G. And the bullet is moving to the left. That's the direction of motion. And that is basically the free body diagram of the system. Now then, let's develop a mathematical model of the system. To do that, we're going to use Newton's law as usual, which states that the sum of all the forces in the x direction is equal to mass times acceleration, also in the x direction. Now we pick left as positive because it's moving to the left. Now that means the net force will be minus 0.001 v squared is equal to the mass, which is 50 over 1000, multiplied by acceleration. Now we always change acceleration to dv over dt since we're looking for the velocity against time in this problem. So v squared equals, now this is going to cancel with this, so we're going to have 5 of divided by 100, which is 0.05, and that's going to be dv over dt. So that is the differential equation dE. It's the equation that describes the motion of the system with respect to time. Now then, we need to solve this equation, and in order to solve it, we're going to use separation of variable methods. Now, first things first, we need to separate the variables. So that means putting v on one side and putting t on the other side. So let's start by moving the 0.05 to this side. So it's going to be minus 0.001 divided by 0.05 v squared equals dv over dt. And then all we do then is multiply both sides by dt and divide both sides by v squared. I'm also going to include a calculation for 0.001 divided by 0.05, which gives you 0.02. So let's do all that at the same time. So we've got minus 0.02 v squared equals dv over dt. Then we say minus 0.02 equals 1 over v squared dv over dt. Finally, multiply both sides by dt, and our equation becomes minus 0.02 dt is equal to 1 over v squared dv. Integrate both sides with respect to their individual variables. Now, we've separated the variables. Now, time to integrate. The integration of 0.02 is minus 0.02t equals the integration of that, well, 1 over v squared is the same as v to the power minus 2. Therefore, we add 1 to the power and divide by the same number. So v to the minus 1 divided by minus 1 plus a. A is the constant of integration. So you can clearly see from here that this we now have the general solution. It's the solution that produces a family of curves. So we have many values of a, and we can produce a family of curves. But we need to find the specific one for our problem. Now we know when time was 0, v was 120. So when t is 0, v is equal to 120. We can now substitute these values into our equation. So it becomes 0 is equal to minus 1 over 120 plus a. Therefore, a is equal to 1 over 120. So now that we have a, let's substitute it back into our equation. So our equation becomes minus 0.02t is equal to minus 1 over v plus 1 over 120. Now I want an expression for v as a function of time. So v the subject and time on the other side. So I'm going to add 1 over v to both sides and add 0.02t to the sides. Ultimately what we're doing is we're taking this to that side and this to this side. So it's going to become 1 over v equals 0.02t plus 1 over 120. And then after this, we now find the reciprocal. So we flip both sides. That becomes v equals 1 over all of this t plus 1 over 100. That's how we flip both sides, 1 over 120. You can find a common denominator between the two on the left, so they can have the same denominator. So that would be equal to v is equal to 1 all divided by 2.4 divided by 120 t plus 1 over 120. Now, of course, they now have the same denominator. So you can say v is equal to, and then you can take that there and make it the same denominator. So 2.4t plus 1. So 1 over 2.4t plus 1 all over 120. What that allows us to do is flip the bottom to the top because the fraction is in the denominator. So it becomes v equals 120 all divided by 2.4t plus 1. That is the function of velocity with respect to time. So from this we can finish the equation. The question says find the velocity of the balloon when it hits the block. It hits the block after 0.4 seconds. So substitute 0.4 into your equation, 2.4 times 0.4 plus 1. And that will give you 61.2 meters per second. And that's it. We found the speed of the bullet when it hits the block.